So the next Oompa Loompa that moves in is going to live where? Now, let's do this. Let's all agree. Let's save ourselves some time here, shall we? We agree this is the first floor, and that this is the second floor, and the third floor, and the fourth floor, right? So we could just call these floors 1, 2, 3, 4, and this is a special. This is a plush. This is a deluxe up here. So one thing we can do, we can just say that, well, this is a first floor special. We could save ourselves some time by saying a 1S. 1S would be first floor special, and like this would be 2S. And by these rules, this would be a what? What would be up there? That'd be a 4D, okay? Right. So just to save ourselves some time, we can shorten that a little bit. So now we've got our Oompa Loompas moving in. Where's the next Oompa Loompa gonna live? 2P is correct, so it's going to live there. Now this one's a little tricky. The next Oompa Loompa to move in is going to live where specifically? It's going to be 2P, obviously, because there's a lot of 2Ps available, but are they going to live by themselves or alone? Wait, those are the same things. Are they going to live by themselves or with someone? Well, let's think about it. Is it cheaper to live with someone? Doesn't matter. According to Hund's rule, doesn't matter. You're going to pay the same either way, right? So if it costs the same, wouldn't you rather have your own place? And so Oompa Loompas are kind of like you in that regard. So the next Oompa Loompa is going to live there, and the next Oompa Loompa is going to live there. And why did I make him green? Well, it didn't matter. It's kind of random which one moves in first, right? But we know now that we have blue, blue, green, the next one that moves in is not going to pay extra for a third floor special or a 3S. It's going to live in a second floor plush, right? Because that's the cheapest room available right now. And so they're going to, I have a green one ready to go in. Where are they going to live? 2P, which one? First one. And the next one is, the next one I have is also green. And the next one that moves in has to be blue. Lovely. All right. Now, you'll notice there we filled up the second floor plushes before we went to the third floor specials. You might have asked, well, maybe a third floor special is cheaper than a second floor plush. And my answer to that is a fairly complicated thing about predicting which one is cheaper, and there's a rule for that we are going to learn next time, but not today, so we don't care. For today's lesson, all we are going to do is to assume that the first floor is the cheapest always, the second floor is the cheapest, the next cheapest always, no matter what kind of room. Now that's not exactly true, but we'll deal with that later. All right? So, next Oompa Loompa comes in is going to live where? 3S. And the next Oompa Loompa that comes in is going to have to be green and live in the 3S, right? And the next one's going to be the 3P, 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 and then the next one's going to be 3P, 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 and then et cetera, right? You get the idea? And so next we would fill up the 3Ds and the 4Ss and the 4Ps, and we won't worry about the correct order at this point. We'll just kind of assume it goes floor by floor by floor by floor. And so we can now answer a series of questions that really you know just about everything you need to know. Assuming that this pattern holds, and it does, if we go to the 5th, 6th, 7th, we didn't talk about any floor above the 4th, but we could arbitrarily go up as high as we wanted to. And so what let's ask questions like this. How many, if you're watching this on video, you're not going to see much for a while, but you can kind of follow along with the questions. On the first floor, how many rooms are there? What? 1. How many types of rooms are there on the first floor? How many types of rooms on the second floor? How many types of rooms on the third floor? How many types of rooms on the fourth floor? How many types of rooms on the 5th floor? How many types of rooms on the 37th floor? 37 is correct. How many? So the floor you're on it tells you how many kinds of rooms there are on that floor. Good. Next, how many actual rooms are on the first floor? On the first floor, there's 1 room. On the second floor, there's 4 rooms. 1, 2, 3, 4. On the 3rd floor there are, count them up, 9 rooms. On the 4th floor there are, count them up, 9 plus 7 is 16, right? On the 5th floor, see the pattern? 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 16, 5 becomes... It's the pattern. It's a square pattern, isn't it? So the 5th floor would have 25 rooms, and the 6th floor would have 36 rooms. How many rooms would be on the 10th floor? 100 rooms. Good. And the Pauli principle, Pauli's rule, says that you can only put 2 Oompa Loompas in a room, right? So how many Oompa Loompas could live on the 1st floor? 2. How many Oompa Loompas can live on the 2nd floor? 8. On the 3rd floor? It's 18 because you take the number of rooms, which is 3 squared, which is 9, and then double it because you can fit 2 to a room, and you got 18, right? And on the 4th floor you could fit, well, 4 squared is 16, and times 2 is 32, right? So on the 15th floor, how many Oompa Loompas could live? Can you square 15 in your head? It's 225. So how many Oompa Loompas could live there if there's 225 rooms? 450. And so there are patterns. There are a lot of patterns here. And it becomes rather easy to kind of see the different patterns. I could ask you just about anything now regarding how many Oompa Loompas could live on a floor. How many Oompa Loompas could live in all of the 3rd floor deluxes? All of them. How many Oompa Loompas could live in all of the 3rd floor deluxes? 10 is correct. How many of the 3rd floor deluxe Oompa Loompas could all have green hair? 5. How many Oompa Loompas with blue hair could live in all of the 10th floor S's? It's just 1, right? Because the 10th floor S's, there's just 1 of them, and only 1 could have that color hair. And so we could actually, so these patterns are pretty simple, and they all kind of go back to this basic apartment complex pattern structure. And now I have to be careful, be prepared here. Are you ready? Are you ready to say that? Are you ready to gasp? Everybody ready? Everybody got your gasp ready? All right, you ready? It turns out I haven't been talking about Oompa Loompas at all day. It's all been lies. Lies, lies, lies. It's all lies. Lies, lies. Weeping. So, yes, I've been lying to you all day long, and it turns out that instead of talking about... Everything I said is true, except I have not, in fact, been talking about Oompa Loompas. You know what I've been talking about? I've been talking about electrons. That is exactly correct. We've been talking about electrons all day long. So, what is what? Well, let's talk about the quantum numbers N, L, M, and S. What did we say that a N stood for? Energy level. And in the Oompa Loompa house, what was an energy level? Energy level was what floor you're on. 1st, 2nd, 3rd, 4th, 5th. What do we say L stood for? That's right, sublevel. What do you suppose that corresponds to? That's the room type. S, P, D, or F. And in an electron, they actually are not special, plush, deluxe, and fancy. They are just S, P, D, and F. That's the labels. Just pure S, P, D, or F. And M, we said, stood for an orbital. So what is an orbital in the Oompa Loompa house? That's right. It's the room. Oop, I dropped a parenthesis there. It's the room. So what floor I'm on is my N value. What kind of room, S, P, D, or F, is determined by my L value. What room I'm in, what orbital, is determined by my m value, and spin is like what? Hair color in my analogy. So, if I know those four things about an electron, its energy, sublevel, orbital, and spin, those are all the things I can know about it, just like all of the things that I could know about an Oompa Loompa are what floor it's on, what kind of room that it's in, which orbital it's in, and what its spin is. Now there are a couple of kind of things that we got to clear up a little bit, got to refine a little bit, because they didn't really, the verbiage didn't really work in my Oompa Loompa skit. So let's talk about Pauli again. Pauli is actually, there's a longer version of his rule. It's called the Pauli exclusion principle. And the Pauli exclusion principle actually says this. It says no two electrons may have the same four quantum numbers. No two electrons may have the same four quantum numbers. And because there are only two spins, just like Oompa Loompas only had two kinds of hair, only two possible spins, that means that you can only fit two to an orbital. And so if we go back up here to the Oompa Loompa house, we could imagine that two electrons could both be on the fourth floor, right? Two electrons could both be on a fourth floor in a deluxe. Two electrons could both be in a fourth floor in a deluxe in this particular orbital. That's our new word for rooms, is orbitals. But if they have the same n value, the same l value, and the same m values, they cannot have the same what? Spin. So if one is up, the other is down. Rather than green-blue, we should start talking about up-down now. You have a spin up or a spin down. Those are the only two kinds of spins, spin up and spin down. And so if we ask any of our old questions that we were kind of cruising through a little bit ago, we're going to answer them exactly the same way, but now we're going to have a slightly different vocabulary. I'm not going to say how many rooms are on the third floor. I'm going to say how many orbitals are on the third energy level. But the answer is going to be the same. It's still going to be 3 squared. It's going to be 9. And I'm not going to say how many Oompa Loompas could live there. I'm going to say how many electrons can exist in that level. And so if we have our little conversion chart between these things, electrons. Oh, by the way, we didn't get to this. What is the apartment complex? What? That's right. The whole apartment complex is like an atom. So this entire building is like an atom. Because just like the Oompa Loompas live in the building, electrons live in atoms. And instead of money, we would think of these in terms of energy. Think of these in terms of energy. And the last little clarifying thing that we need to clean up is, and by the way, Hund's rule is almost, Hund's rule works exactly the same way we said earlier. Because of Hund's rule, electrons will completely spread out within a sublevel until they won't pair up until they have to. So Hund's rule is, it's not stated in terms of, pay by the Oompa Loompa, but it is the reason that things will not pair up until all of the available, until it runs out of things at the same energy. Finally, the last clarification is the Aufbau principle. Aufbau is German for building up. It means essentially that you're going to start at a lower energy. You're going to start at a lower energy and fill up all of the available spaces at the lower energy before you work up to the higher energy ones. And so I believe I am at 14 minutes and 56 seconds, so it's going to stop me now.